Viewers, you are welcome to this video. Today I want to share with you how you can evaluate triple integrals. In my last video, we looked at double integrals. This time I want to look at triple integrals. Those of you who have not watched my video on double integrals, you are advised to go and watch that one so that it will help you to understand this one better. Yes. Now we are going to look at two questions. I believe that if you're able to understand these two questions, then evaluating triple integrals will not be a problem to you at all. Yes, so viewers, please pay attention as we all solve these questions. Let's look at the first one. Solution. I've been asked to evaluate this triple integral 1, 2, 3 because you have three integral signs. That's why we are saying that it is triple integral. Yes. So let's look at it. So this is solution to 1. We have integral from 1 to 2, integral from 0 to 1, integral from 0 to 1 of x plus y plus z of z dx dy. Yes. Now let's look at this one. Now viewers, before you continue this, let me explain this to you. You see, when you have something like this, integral from say 1 to 4, integral from 2 to 5 of anything at all, let me say x squared plus a y dx dy. Now this one, when you solve this, it is the same as when you change this one into this. Integral from 2 to 5, integral from 1 to 4 of x squared plus y dy dx. Now when the limits of integration are all constants, when they are all numbers and they are constants, then this is true. This is equal to this. You see, integral from 1 to 4, 2 to 5 of this dx dy. So if I bring this one first, then I have to reverse the dx dy to make it dy dx. This is true. Yes. And this is true only when all the limits of integration are constants. They are numbers. Are you seeing it? If I change this one to maybe x, there is no way the solution to this one will be the same as the solution to this one. So you have to take note of this. Okay. Now let's move on to the triple integrals. The same thing applies to the triple integrals. Yes. The same understanding can be extended to this one. Now let's look at this one. Those of you who avoid the video on double integral, I told you that I have to start from the internal one. So in this case, because there are three, I have to start from the innermost one. Do you see it? So we are going to start from here. And then when you finish, then you move on to the dy, then move on to the z or the z. Are you seeing it? So you have it this way. So this is equal to integral from 1 to 2, integral from 0 to 1 of this one. We are going to integrate this one with respect to x. So this one will be x squared over 2. This one will be xy. This one will be xz because you are integrating with respect to x. Then let's put in the limits 0 to 1. dy dz. I see it? So you have it this way. Now let's evaluate this one. Because you integrated with respect to x, wherever you see x, you are going to write 1. get the answer, and then wherever you see x, you are going to write what 0, and then you subtract. Isn't it? So you are going to have this. So this is equal to integral from 1 to 2, integral from 0 to 1. Now, when you put in 1, wherever you see x, you are going to get, if you put 1 here, 1 squared is 1, so 1 over 2. Are you seeing it? And then when you put 1 here, you are going to have y. When you put 1 in place of x, you are going to have z. Now, when you put in 0, wherever you see x, this one will be 0, this one will be 0, this one will be 0. So minus 0. So you can decide not to bring that one. It's okay. So you have it this way. dy dz. You don't rush in mathematics, you have to take your time and make sure that the writing has been done. So you have it this way. Now, so you are going to continue. You started with the innermost one. Now you are going to continue with the inner one this way. Are you seeing it? You are going to continue this one. So this is equal to integral from 1 to 2. We are going to integrate this one with respect to y. With respect to y. So this one will be 1 over 2y plus y squared over 2 plus yz. And then you put in the limits. You are going to put in the limits. So if you put in the limits, let me just do it this way. The limits are 0 and 1. So dz. Are you seeing it? So it means that wherever you see y, you are going to write 1. And when we finish, wherever you see y, you are going to write 0 and then you subtract. So this one is equal to integral from 1 to 2. Now when you put y here, you are going to have, when you put 1 here, you are going to have 1 over 2. Put 1 here, 1 over 2. Wherever you see y, yes. Now when you put 1 here in place of y, I'm going to have z this way. Now wherever you see y, if you put 0, this one will be 0, this one will be 0, this one will be 0, so minus 0. So there's no need for you to do. So dz this way. Now this is the same as integral from 1 to 2. Half plus 1 over 2 plus 1 over 2 is 1. You are going to have 1 plus z. dz. Like this. Now this is equal to, you are going to integrate this one with respect to the whole of this with respect to z. So this one will be z. If you integrate this one, you're going to get z. And then this one will be z squared over 2. Now let's put in the limits. 1 to 2. This is equal to, when you put 2 here, you are going to get 2 plus, when you put 2 here, this one will be 2 squared, that is 4, over 2. And that is 2. Are you seeing it? Minus, when you put in 1, wherever you see z, this one will be 1 plus, when you put 1 here, this one will be 1 over 2. So this is 4 minus, now 1 plus 1 over 2 is 1.5, and 1.5 is 3 over 2. Are you seeing it? So here, this is over 1, the LCM is 2. 1 goes here 2 times this 8. 2 goes here 1 times this 3. We are going to have 5 over 3. Yes, 5 over 5 over 2. Sorry, yes. The down one is 2. So 5 over 2. So it means that the solution to this one, this triple integral, is 5 over 2. Yes. Now, having understood this, let's look at the second question. Then you can say goodbye to this lecture. Yes. So let's look at the second one. So we are done with the first one. Let me clean it. Let me clean the first one. And then look at the second one. Solution to the second one. Solution. Now, this one. This is the question. Integral from 0 to 1, integral from y to 1, integral from 0 to 1 minus x of x, dz, dx, dy. This is the question. So you have to start. You are going to start from here. You are going to start with this one. This one, the innermost one. Yes. So this is equal to integral from 0 to 1, integral from 1 to y to 1 of this. You are going to integrate this one with respect to z or z. So if you do that, you are going to get x, z. And you put in the limits 0 to 1 minus x, dx, dy. Are you seeing it? It's a gradual process. You don't have to rush. This is equal to integral from 0 to 1, integral from y to 1. Now, because you integrated with respect to z, it is that wherever you see z, write 1 minus x. Are you seeing it? So this one will be x times 1 minus what? X. That's the first one. And then minus, when you put in 0, but when you put in 0, the whole of everything will go to 0, so there's no need for us to write it. So we have it this way. So we have it this way. dx, dy. That is equal to integral from 0 to 1, integral from y to 1 of, let's expand this one. This one is same as x minus what? X squared. dx, dy. Are you seeing it? Yes. Now we are left with these two. So let's continue with the inner one. This one. I'm going to continue with this one. We started with the innermost one. I'll continue with the inner one. Then the last one can be right this way. So I'm going to integrate this one with respect to x. Are you seeing it? With respect to x. Now this one is equal to integral from 0 to 1. Are you seeing it? You are going to integrate this one with respect to x. So this one will be x squared over 2 minus x cubed over 3. When you integrate this one, this one. And then we are going to put in the limits. Let's put in the limits of integration. There are y and 1. dy. This is equal to, what this means is that because you integrated with respect to x, what this means is that wherever you see x, you should write 1. You get the answer when you finish. Wherever you see x, you should write y and then subtract. So this one is going to be integral from 0 to 1 of, now when you see x, you are going to write 1. So this one will be 1 over 2 minus 1 over 3. When you put 1 here, 1 cubed is 1, 1 squared is 1. Minus, when you put in y, wherever you see x, when you put y here, this one will be y squared over 2. Minus, look on the board though, minus y cubed over 3. Like this. dy. I have it this way. So this is equal to integral from 0 to 1. Right? Now, let's try to open this one. 1 over 2 minus 1 over 3. 1 over 2 minus 1 over 3. SCM is what? 6. This comes here. And then this one comes here 2. So 1 over 6. Then this one will be 3. Yes. 1 over 6. So this is 1 over 6. These two. Minus y squared over 2. And then here, look on the board. Negative 1. Times negative y cubed over 3. Negative times negative positive. You have to be very careful. So plus y cubed over 3. So that will be this way. Dy. We are now going to integrate this one with respect to y and do the evaluation to get a final answer. So this one will be, if you integrate this one with respect to y, this one will be 1 over 6y. And the same as y over 6 minus, if you integrate this one will be y cubed over 2 times 3. You see that y squared, when you integrate it, it will be y cubed over 3. So that will make it y, I said it, y cubed over 2 times 3. So that is 6 plus This one, when you integrate this one will be, let me write this 3 well. This one will be y raised to the power 4 over 4 times 3, so 12. Then let's put in the limit 0 to 1. Now, wherever you see y, you're going to write 1. So this one is 1 over 6 minus 1 over 6, because 1 raised to the power 3 is 1. Plus, when you put 1 here, 1 raised to the power 4 is 1, so 1 over 12. Isn't it? Now 1 over 6 minus 1 over 6 will be 0. So you're going to have 1 over 12. Yes, so the answer to this one is 1 over 12. So viewers, you have seen that it is not difficult at all. Evaluating triple integrals is not difficult at all. And I believe that if you have really understood this, then you should be able to evaluate any triple integral at all. Thank you very much for your attention. For more of this video, subscribe to my YouTube channel, Shamalaa Jnr. Thank you very much.